Sorry, I'm late. No, I was having problems with my internet connection. Okay. Again, no, my intent is just to give you a lot of sample problems showing the power relationships in AC circuits. But before that, let's do a little bit of review of what we took up last Tuesday. Okay, so these are summary of the power equations involving AC circuits. First, you have real power. Real power is defined as the RMS voltage multiplied by the RMS current multiplied by the cosine of the phase angle between voltage and current, and that's watts. And if you have a resistor, real power is IMS current squared times R, or the RMS voltage times the RMS current. Okay, real power is the power that is convertible to work or convertible to heat. In other words, real power is the power that does something for us. Then we took up reactive power, the symbol for reactive power being Q. So the formula for Q is RMS voltage times RMS current times the sine of the angle, the phase angle between the voltage and current. And the unit for that is volt amperes reactive bars. For an inductor, the reactive power is equal to the RMS current squared times X of L. And for a capacitor, it is the negative of the RMS current squared times X of C. And then we took up apparent power, which we gave the symbol S. And this is simply the magnitude or the RMS voltage multiplied by the RMS current. And the unit for apparent power is volt amperes. Okay. Next, we took up power factor. Power factor is the ratio of apparent power over, the ratio of real power over apparent power. So that's P over S. And from the formula, because VI is equal to S, P over VI is simply cosine of the phase angle between the voltage and the current phasor. But you have to specify whether the power factor is lagging or leading. Finally, we took up complex power. This wasn't part of my summary before. We took up complex power. And this is the only time where I use a complex number in the power relationships, because everywhere else here, there is no complex number here. These are all real numbers or scalar quantities. So here, complex power, and we give it the symbol S with the vector sign on top, and that is only to differentiate it from this S. But actually, itong S na to is not a phasor. It is not a phasor. Okay, this is equal to the phasor voltage multiplied by the conjugate of your phasor current. And if you convert that to rectangular form, that is your real power plus J times your reactive power. That's why sometimes reactive power, people have this notion that it's also imaginary power. But actually, it is by no means imaginary, because it has, it manifests itself. There's a manifestation of reactive power in an electrical system. The unit for complex power is also volt amperes. It's a voltage times current, so it is volt amperes. Okay, just in terms of notation. Of course, you know this. This is the phasor V. When I say something like this implies that this is the RMS value, RMS voltage. In other words, pag hindi ko linagyan ng VRMS or V effective, ang implication is that is the RMS voltage. That's why phasor V is just V at an angle of theta V. This is the phasor. This is the magnitude of the phasor, which is your RMS voltage, and then this is your phase angle. So lahat itong terms na to, these are all RMS values. No? VI, those are all RMS values. So dito lang tayo nagkaroon ng phasor, dito sa expression na to. Okay, then last time I said, it's very easy to remember these relationships if you think of a right triangle, okay, whose diagonal is equal to apparent power, okay, and then you have the height is your reactive power and the base is your real power. Okay, so remember S is equal to VI. So it's very easy to see that P is equal to S multiplied by the cosine of this angle. But what is this angle? This angle is the phase difference between your voltage phasor and your current phasor. So that's theta V minus theta I. No? Remember, it's the voltage minus the current, theta V minus theta I. So if you see this, P is S cosine of this angle. So that's our expression which we derive for real power or power. No? Then Q is just VI sine of theta V minus theta I. So if you know this triangle, you know that S is also the square root of P squared plus Q squared. And you know that Q over P is equal to the tangent of theta. So if you're given any two quantities here, you can compute for the other two. I think I mentioned that in the last lecture. Any questions? Any questions? Okay, so let's go to some example problems. So here's the first example problem. I took this from the notes that were distributed by Dr. Nervous. A sinusoidal voltage having a maximum amplitude of 625 volts is applied to the terminals of a 50 ohm resistor. Find the average power delivered to the resistor. So can I ask you to just solve this right now using your calculators? And can you tell me what you think the answer is using the chat box? Okay, please give it a try. No? Please give it a try. So ano yung sagot dito sa letter A? No one? Okay, I have some answers already. A few more, no? I'm waiting for a few more. Si yeah, no. Si John Edric at saka si Eric, medyo mali yata yung sagot. Mali yung sagot ninyo, no? Okay, the correct answer, si Rick at saka si Justin got it right, ano? It's a 3.91 kilowatts. So ano yung scenario natin rito, no? I have a voltage source. Okay? The amplitude of my voltage source is 625 volts. No? Amplitude, no? So my voltage source is of the form 625 cosine omega t plus, let's say, voltage theta of V. So this is my amplitude. Let me make that a little cleaner. No? Medyo madumi. So I have a voltage source, and this is 625 cosine omega t plus an angle theta of V. And this is applied to my resistor, which is 50 ohms. So the question is, find the average power delivered to the resistor. What is the average power delivered to the resistor? Your P average would be the RMS value of your voltage squared, VRMS squared over R. But what is VRMS? So this is 625 over the square root of 2. That is VRMS. So you square this, divide by 50, and the answer you'll come out with is 3906.25 watts, which is approximately equal to 3.91 kilowatts. So tama yung 3.91 kilowatts. Okay, I'm suspecting the rest of you forgot to divide by square root of 2. Tama ba? So that's why you came out with 7 point whatever, no? Sagot na ninyo 7.8, no? Which is 3.91 times 2. Okay, so remember, no? The average power depends on the RMS value of the voltage. No? Now, ito yung letter A, ano? Now I could have computed for IRMS. Okay, IRMS is just VRMS over R. And if I computed for IRMS, okay, what is this? I'm going to get, this is 625 over the square root of 2 all over 50. No? So I'm going to get, what is this? 625 over 50. This is 25 over 2 times the square root of 2 amperes. So I can also compute for my average power. This is IRMS squared multiplied by R. So this should give me the same, no? 3906.25 watts. Okay, para hindi masyadong mahirap magsulat in subsequent examples, tatanggalin ko na yung subscript RMS, ano? Basta the understanding is if I don't put any subscript, then that's understood to be RMS value. Okay. So let's take another example. Calculate the average power and reactive power to the terminals of the network shown in figure 10.6. So this is figure 10.6. Itong figure na to, that's this. Okay, where you have a voltage across the terminals given by this expression, and you have a current flowing through the terminals given by this expression. Okay. Take note that the passive sign convention is applied. No? This follows the passive sign convention. Naalala niyo yung passive sign convention? According to passive sign convention, we assume that the element is a passive element, and therefore the current flow is in the direction of potential drop. No, because if it is remember, if it is a passive element, then as the charges are flowing through the element, the charges lose energy. And therefore, if the charges lose energy as it flows through the element, then the potential at the top terminal would be higher than the potential at the bottom terminal. So this follows the passive sign convention. Okay, so how do you calculate the power and the reactive power? Okay, so what is P? P is equal to VI cosine theta V minus theta I. Okay, ano yung value ng V? Can somebody shout out? What is the value of V? I-shout out na lang niyo, huwag na niyo i-chat, no? Para hindi ko nabubuksan yung chat box.
Sir, 70.7 volts.
Yeah, 70.7, no? Because that's, let's just say 100 over the square root of 2, no? Because we have to get the RMS value of your voltage, right? And then ano yung value ng I? Same thing, ano? 4 over, well, same process, 4 over the square root of 2. So what is the angle which I will get the cosine of? What is the angle that I have to get the cosine of?
30 po.
30.
Wait.
Warning. Take a look at your I function. No? Madaming nahuhuli dyan, ano? Take a look at your...
120 po ba?
Ano yan?
120 po ba?
Yeah, it's 120. No? Can you explain, Rick, why it's 120?
Kinonvert muna po yung sine into
Okay.
cosine.
Yeah. You have to convert the sine into cosine, and so you have to subtract 90 degrees from the angle. So this becomes actually, yeah, this is 4 cosine of omega t minus 105 degrees amperes. Okay? Madaming nadadali dyan, ano? So anyway, if I compute for P, I'm going to get, okay, I have the answer here, no? First of all, my cosine, I'm getting the cosine of an angle that is greater than 120. So expect the cosine to be less than 1. Di ba? Kasi yung cosine mo positive lang from 0 to 90 degrees. Right? That means you're in the first quadrant. Kapag mas malaki na ng, kapag between 90 and 180 degrees, negative na yung cosine natin. We're already in the second quadrant. No? So this is going to come out to minus 100 watts. So anong ibig sabihin ng negative 100? Anong ibig sabihin ng negative P? If you follow the passive sign convention. Can somebody tell me? Nakalimutan na niya yung power. I'll call out people, ano? Si John, ano palagay mo, John? John Edric, are you there?
Sir, pa-repeat po ng question. Sorry po.
Yun, no? Yung P lumabas negative 100 watts. Anong ibig sabihin itong negative na P?
Sir, nagde-deliver po ng power?
Yeah, no? In other words, this element is not absorbing power. It is delivering power. Yun ang ibig sabihin nitong negative, no? So the element, the network here, delivers power. Okay, so that's P. So yung Q ko is just VI sine of 120 degrees. No? Remember, this is P, this is Q. And I have here the answer. This is 173.2 bars. 173.2 bars. No? So what does this mean? Well, this means that my network or my element is absorbing. So here, the network is absorbing reactive power. It is delivering real power, but it is absorbing reactive power. So yun yung sagot nito ng letter B at saka letter C. Now I want to show you an alternative solution. And I'm going to use complex power. Okay, what is the equivalent phasor of V? No? The equivalent phasor of V is equal to 100 over the square root of 2 at an angle 15 degrees. Right? 100 over the square root of 2 at an angle 15 degrees. And the equivalent phasor of I is equal to 4 over the square root of 2 at an angle 120 degrees. This is amperes. Okay. What is our formula for apparent power? Apparent power is equal to the phasor voltage multiplied by the conjugate of your phasor current. So this is 100 over the square root of 2 at an angle 15 degrees multiplied by 4 over the square root of 2. Ano yung conjugate ng I? Ano mangyayari dito sa angle na to? Anyone?
Wait lang po, sir. Hindi po ba negative 105 yung sa I, yung angle niya?
Ay, sorry. Yep. Sorry. You're right. Okay? Buti yun. Hindi kayo natutulog, no? Minus 105 degrees. You're right. Okay? So ano yung conjugate ng I? What will this angle be?
105.
Yeah, this will be 105. If I multiply these two phasors together, so you multiply the magnitude and then you add the angles, this is going to be, okay, this is 400 over 2, so that's 200 at an angle of 120 degrees. Sorry, dun nanggaling yung 120 degrees, no? My mind was racing forward. Now, if you convert this to rectangular form, okay, how do you convert that to rectangular form? Well, madali with your calculator, no? You just enter 200 at angle 120, and then you do an operation polar to rectangular, no? But if you don't have a calculator like that, it's the real part is 200 cosine 120, and the imaginary part is 200 sine of 120. So if I convert this to rectangular form, I'm going to get minus 100 plus j 173.2. Now the unit for S is volt amperes. In other words, this combined complex number is in volt amperes. Okay? But we know that S is equal to P plus JQ, meaning to say this must be my P and this must be my Q. And notice that is consistent with this. No? This is my P and this is my Q. So you have two ways of solving this problem. One is by applying the definition of real power and reactive power. The other is by using the complex power formula. Are there any questions? Walang tanong? Okay, let's continue. Now I have some other examples, still taken from the notes that were published. No? So let's just do this until until the end of the class. Okay, so this is my third example. Okay, in the circuit shown, V sub t is 311 cosine 377t. So we know that 377, alam na niyo yan, ano? That's your 60 hertz. So in effect, in fact, yung 311, 220 volts yan. No? More or less, this is your household voltage. 60 hertz at 220 volts RMS. So find the power and reactive power delivered to the load. Okay. So again, there are many techniques for solving this problem. Okay, let's do this. First of all, let's do it the traditional technique, no? So the traditional method. Okay. Okay. I first transform the network, no? So transform network. What will my transform network look like? Okay, I'm going to have, okay, 311 cosine 377t is equivalent to 220 at an angle of 0 degrees. This is in volts. Okay. Yung 3.06 millihenries, no, that's omega L, J omega L. This is going to be equal to J 1.154 ohms. Ito namang 12.85 millihenries, okay, this is going to be equivalent to J 4.846 ohms. You just follow Z's of L is equal to J omega L. So I have here zero point 0.5 plus J 1.154, and then my load, this is going to be my load, okay, my load is 7.5 plus J 4.846. So this is ohms, and this is also ohms. Okay, what can I compute for now? No, I can compute for I. Okay. So what is the phasor value of I? I is just 220 at an angle 0 degrees, that's my voltage, divided by my total impedance. Divided by, okay, this is 0.5 plus J 1.154 plus 7.5 plus J 4.846. Can you still follow? Are you still okay? So nasusundan pa nyo? Okay, good, no? And again, this is just calculator lang to. I'm going to get 22 at an angle minus 36.87 degrees amperes. By the way, no, itong scheme na to, where I have a load and then I have an impedance here, this is very typical of electrical systems. So this is my actual load, and then this impedance is actually the impedance of my transmission line. It's what connects my source. This is my source, this is my load. Between my source and my load, I have what you call a transmission line. If that transmission line is short, then this can be neglected. But if that transmission line is long, then you have to take into consideration the impedance of your transmission line. And your transmission line is usually, or almost always, it is inductive. Again, in transmission line natin, almost always it is inductive. So it will consist of a resistance in series with an inductance. Okay. I can already determine the power and reactive power delivered to the load. How do I do that? Any suggestions?
Complex power ba?
For complex power, I would need to know the voltage across the load, right? Because if I want to get the power across the load using complex power, dapat alam ko yung voltage across the load. Alam ko na yung current through the load, no? Pero kailangan malaman ko rin yung voltage across the load. So pwede yun, no? But how do I get the voltage across the load?
Voltage division.
Yeah, that's one way. Voltage division, no? So sige, let's do that, no? Gawin natin 'yun. So let's get the voltage across the load. So ang suggestion is voltage division. So let's say this is V sub L. Wag dito, no? Plus or minus V sub L. So actually dito, this should be small V sub L of T, no? So this is V sub L. So by voltage division, V sub L is equal to 220 at an angle 0 degrees multiplied by, let's just call this Z1 and Z2, no? Z1 and Z2 multiplied by Z2 all over Z1 plus Z2. Okay? So alam na nyo kung ano yung Z1 dito, alam na nyo kung ano yung Z2 rito. So that I can just put the answer, no? I don't spend too much time writing out. Okay, if I do this, this is 196.45. I have the answer already here at an angle of minus 4.0 degrees. And this is in volts. And then ang suggestion ni, was it Rick that suggested it? Okay. I can get the complex power delivered to my load. So this is going to be the phasor voltage across my load multiplied by my load current, the conjugate of my load current. But note that, but IL is equal to I. If you notice, my load current is just equal to I. So load voltage times conjugate of the load current, but my load current is equal to I. So what is S of L? This is now 196.45 at an angle minus 4.0 degrees. And then I of L is 22. But since I'm getting the conjugate, that would be 36.87 degrees. So this is 22, 36.87 degrees. Okay. And if I do this, I'm going to get 3,630 plus J, 2,346. This is volt amperes. But I know that this is going to be P and this is going to be Q. So P is 3630 watts and Q is 2346 watts. Okay, so that's one way. Anybody can think of any other way? Actually, from what I showed here in this slide, you can already go directly to the computation of P and Q. How? Okay. So another way. Okay, remember this is my load. If I take a look at my load, no? This is 7.5 plus J 4.846. So this is 7.5. And then this is J 4.846. Tama ba? Yeah, 4.846. And I have this current I flowing, which is 22. Tama ba? 22 at an angle minus 36.87 degrees. Still no idea how to get P and Q using this information?
Sir, yung I squared R.
That's right. No, that's right. The P delivered to my load is the RMS value of my current, which is 22. Let me just say I. No? Basta sinabi kong I na walang arrow, alam nyo hindi phasor yon, tsaka alam nyo RMS value yan. So this is I squared R. So this is 22 squared multiplied by 7.5. And that will give you exactly this, no? 3630 watts. And Q, okay, will be I squared X of L, no? So this is RL XL, no? The resistance of my load and the reactance of my load. So this is 22 squared, okay, times 4.846. And that will give me exactly 2346 watts of bars.
Wait, so sir, pwede siyang i-shortcut with complex power equals I squared Z? Pwede po ba yan?
Complex power equals, paano yan?
I squared Z.
No. that's not complex power. Complex power is voltage times the conjugate of the current. No? There's no such thing as I squared Z.
Okay.
Unfortunately, it doesn't work that way. No? Although nice try, no. Pero hindi ganun nagtatrabaho yun. Well, actually, in effect, parang ginawa mo na rin yun dito if you think about it, ano? Except that yeah, if you think about it, ganun na rin yung effect nito, di ba? Rick?
Yeah po.
Okay. Although that is not the definition of complex power, no? That's not how complex power is defined. So any questions? No? So I showed you two ways, no? So obviously dito, well, ang maganda dito, pag alam ko na yung RMS value ng I, okay? Hindi na ako kailangan mag-complex math, no? If I know the RMS value of I in the second method that I showed, there's no more complex math that I will need, no? Because I just get this RMS value, square it, multiply it by 7.5, that gives me P, square this, multiplied by 4.846, that gives me Q. No? Unlike this particular solution where you use complex math, no? Although, maybe I should mention that it's not really an issue nowadays anymore to use complex math because you have your calculators. No? Nung panahon namin na wala kaming mga calculators, issue sa amin yung complex math because we had to perform the sine and cosine functions manually. No? And hate to admit it, when I entered the College of Engineering, we didn't even have scientific calculators. We had to use trigonometric tables or the slide rule to get the sines and cosines. That's how old I am. No? So nung panahon namin, we really did not like to use complex math. No? So we would always prefer this type of solution. But now that's not really an issue because you have your calculators that can perform this type of solution. Okay, let's take another example. Okay, so find all real power and reactive power. When I say all real power and reactive power, that is the real power and reactive power delivered by the source, and the real power and reactive power that is absorbed by this impedance, and by this impedance. Okay. So how do you suggest we solve this problem? Well, almost always, pag ganito yung problem, when you see a problem like this, no, the first thing that you have to do is you transform the network. So your transform network will look something like this. No? Okay, you have 200 over the square root of 2 at an angle 0 degrees. Okay, let me just put the values already. No? Let's call this Z1. Let's call this Z2. And let's call this Z3. Okay, where Z1 is equal to 6 plus J12. No, omega is equal to 10, L is equal to 1.2, so J omega L is equal to J12. Z2 is equal to 5 plus J5. Tama ba? Yeah, 5 plus J5, yeah. By the way, this is ohms, this is ohms. And Z3 is equal to, okay, this is minus J over omega C. Omega C is 10 times 0.01, so that's 0.1. So you get the reciprocal of that, that's 10. Yeah, that's right, that's 10. So this is minus J 10. This is ohms. Okay. Now what we want to compute is, let's call this I1, let's call this I2, and let's call this I3. Okay, I'm going to give you the values of I1, I2, I3 already, no? Because, okay, how do you compute for I1, I2, I3? Diba? This was actually an example we had earlier. So what are the suggested methods for computing for I1, I2, I3? I think we discussed several methods. One is you use a nodal analysis, right? You apply nodal analysis to this node, using this node as a reference. And then you set up your nodal equations, and then you can compute for this voltage. Kung alam mo na itong voltage na to, then I1 is just 200 over the square root of 2, then angle 0 minus this voltage over Z1, and then I2 is this voltage over Z2, and I3 is this voltage over Z3. No? So anyway, here are the answers. No? So you can just do this on your own. So this is going to be, yeah, let me just give you 7.071 at an angle minus 36.87 degrees amperes. I2 is equal to 10 at an angle of minus 81.87 degrees amperes. And I3 is equal to 7.071 at an angle of 53.13 degrees amperes. That's I1, I2, and I3. Okay. So what is the total power delivered to Z1, Z2, and Z3? Okay. Let's call that P total, no? P total. Kung alam ko na yung RMS value ng I1, ano ang power delivered to R1? power delivered to R1 is the RMS value of I1 squared multiplied by 6. So this is going to be I1 squared times R1. Yeah. Okay. And the power delivered to R2 is just I2 squared times R2. Is there power delivered to Z3? None. No? There's no power delivered to Z3 because Z3 has no real component. Z3 is purely imaginary. So the total power, and let me just give it to you. Okay, this is going to be 300, and this is going to be 500. So the total power, this will be 800 watts. Okay, the total reactive power delivered to Z1, Z2, and Z3, total reactive power delivered to Z1, Z2, and Z3, let me call that Q total. Okay. The total reactive power delivered to Z1 should be RMS value of I1 squared times, not 1.2, no? Times 12. Times 12. Okay? So this is I1 squared times, let me call it X1. So this is R1, this is X1, R2, X2, and then let's call this X3. No? Okay. Plus I2 squared, no, the RMS value of this multiplied by X2 times 5. X2. Okay, now here's the thing, no? With the capacitor, okay, the reactive power delivered by a current to a capacitor is always negative. Well, you can also relate it to the capacitor having an imaginary component which is negative. So this will be minus I3 squared times X3. Okay. So note that this is the reactive power to a capacitor. Which is negative. Okay. So if you compute for that, actually this comes out to, I have it here. This is 600 vars. This comes out to 500 vars. And then this is minus 500 vars. So if you compute that, this just comes out to 600 vars. So that solves the problem. Well, that's the power and reactive power delivered to the network, you know. Let's try to get the power and reactive power delivered by the source. Okay. So what is this? This is the source voltage Vs. That's 220 at an angle 0 degrees. And what is our source current? Is I1. The source current is I1, which is 7.071 at an angle of minus 36.87 degrees. No? So this is volts and this is amperes. So what is the real power delivered by the source? Let me call that PS. No? So real power delivered by source. So that's PS. That would be equal to V of S I1. Okay, I took out the vector sign. So assumption is this is now RMS values, no? Cosine of 0 minus negative 36.87 degrees. Okay. And if I compute for that, so this is according to the definition. No? This is VI cosine theta, where theta is the difference in angle between your voltage, that is 0, and your current, negative 36.87 degrees. No? So this is just going to be 220 multiplied by 7.071 cosine of 36.87 degrees. And you are going to get exactly equal to this, 800 watts. No? On the other hand, QS is going to be VS I1 sine of 36.87 degrees. And this is going to give you 600 vars. Okay. Notice that the power delivered to the source, delivered by the source, is equal to the total power absorbed by the impedances. So that's law of conservation of power. Same thing with the reactive power. The reactive power delivered by source is equal to the total reactive power absorbed by the impedances. Okay. By the way, is there an alternative way of getting P of S and Q of S? Can you tell me?
Complex power?
Yes, complex power again. No, I could have gotten P of S and Q of S by the complex power formula. No, so S of S, okay, is V of S multiplied by I1 conjugate. And this would have given me 800 plus J 600 volt amperes. So I'm just showing you that there's more than one way to solve problems here. Any questions with regard to this example? Okay, let's discuss this one last example. No, medyo mahaba-haba to, no? Okay, and this is what I was earlier telling you, no? This is very typical of a problem you would encounter in industry. So ganito yung mga problema na nakikita nyo in real life, no? So you have a shop, an industrial shop, and these are the different loads that you have in the shop. So meron kang induction motor, meron kang electric heater, meron kang lighting load, and meron kang mga outlets. Now your induction motor pag tinignan niyo yung motor, meron yan tinatawag na nameplate sa motor, no? That nameplate will tell you what is the motor voltage, what is the motor current, but not that nameplate will also tell you how many kilowatts the motor is, and okay, more often than not, it will also tell you what is the power factor of that motor. So the induction motor in my shop consumes 2 kilowatts at 0.85 power factor lag. My electric heater is 3 kilowatts. Now, why is it one power factor? Because usually a heater is purely resistive. Walang inductive element usually yung electric heater. That's why you have a one power factor. And then my lighting load, I have 500 watts of total lighting, and the total lighting was determined to be operating at a power factor of 0.9 lagging. And I also have outlets, and the typical load that my outlets post is 1 kilowatt at 0.95 power factor lagging. The voltage across the load is given in RMS, 220 volts RMS. So the problem is to find the current through each load and the total current supplied by the shop. So how does this scenario look like? First of all, I have my 220 volt line. This is my 220 volt line. Okay, so yan, no? Okay, so assumption is, okay, this comes from Meralco. And this is 220 volts RMS. And all my loads are in parallel. So this is L1. This is L2. This is L3. And this is L4. I have a total current being supplied to my load. Let me call that IT. Okay, my total current. And I have individual currents flowing here. I1, I2, I3, and I4. Let's consider each load separately. So consider each load separately. So starting with L1, okay, L1 is 2 kilowatts at 0.85 power factor lag. Power factor lag. Okay. Now the voltage across all my loads is 220 volts RMS. Tandaan nyo yan. Ano? You remember our power triangle? Okay. Power triangle. This is S. This is Q. This is P. What is this angle? This angle is theta, where theta is the cosine, arc cosine of 0.85 degrees. Okay. Now what is your formula for P? P is equal to S cosine theta. P is equal to S cosine theta. So this is 2 kilowatts. 2 kilowatts is equal to S multiplied by 0.85. So right away, I can compute for S. Right? The value of S is 2000 over 0.85. I don't have that figure here. Okay, this is 2.35. Unfortunately, somebody answered, no, it's not kilowatts, no? Because S is volt amperes, P is watts, and Q is vars. No, so this is kVA, kilovolt amperes. Remember, S is volt amperes, P is watts, and Q is vars. Okay, but what is S? S is actually V times I. Right? By the way, let's call this P1. No? P1 is equal to S1 cosine theta 1. No? So S1 is equal to 2.35 kVA. So S1 is equal to V times I1. No? But V is 220 volts. Right? So right away, I can compute for I1. I1 is 2.35 kVA all over 220 volts. No, I'm going to get 10.68 amperes. Any question how I got this? Any question? That's L1. Let's take a look at L2. Okay, so let me just remember this, no? Yung L1, let me mark this, no? Ito yung I1, no? I1 yan. Okay. Let's take a look at L2. L2, I have an electric heater, 3 kilowatts at 1 power factor. Right? So P2 is equal to 3 kilowatts. So this is 3 kilowatts. Okay. But what is this? No? This is equal to VI2 times your power factor, PF2. But my power factor is equal to 1. No? This is 1. So this is just equal to V times I2. Right? So right away, I can compute for I2. I2 is equal to 3,000 or 3 kilowatts divided by 220 volts. Okay. And this is going to give me 13.664 amperes. Okay. So that's my I2. Any question how I got I2? So pretty straightforward, no? I know my kilowatts. I know my power factor is 1. And therefore, this is V times I times power factor, but power factor is 1. So it's just V times I. So 3 kilowatts divided by V, which is 220, I get 13.46. Okay, what about L3? Okay. What about L3? Load 3. So 500 watts, 0.9 power factor lag. So again, no? S3 is equal to P3 divided by your power factor. So this is 500 divided by 0.9. And I'm going to get S3 is going to be 555.56 What is the unit? This is volt amperes. Volt amperes. But S3 is equal to V times I3. And therefore I3 is equal to 555.56 divided by 220. And I'm just going to get 2.53 amperes. So this is I3. Finally, meron tayong load 4, 1 kilowatt, 0.95 power factor lag. No? So ito yung load 4. Okay, P4 is equal to 1 kilowatt. This is V times I4 times your power factor, no? Which is your cosine theta. Okay. So this is equal to V times I4 times 0.95. Anyway, what I'm going to get is I4 is equal to 1,000 over 220 divided by 0.95. This gives me 4.78 amperes. Okay, I have I1, I2, I3, and I4. So question, can I just add all of these currents together to get I of t? Yes or no? So I have somebody that said yes. Anybody else? Okay, so you're all saying yes, or no? Unfortunately, the answer is no. Okay, the answer is no. Okay. Now, I1 is not equal to I1 plus I2 plus I3 plus I4. However, I1 is equal to I1, sorry, IT, no? IT is equal to I1 plus I2 plus I3 plus I4. Do you see the difference? Nakita ba niyo yung difference? So ito hindi niyo pwedeng gawin. Right? Because your I1, I2, I3, I4 will not be in phase. You can only do this if all your currents are in phase. Remember that your currents have angles. You can only add the phasors together. No? So when you apply KCL, so this is like a warning. KCL can only be applied on the phasor quantities. Okay, KCL can only be applied on the phasor quantities. Now, I'm running out of time, no? So I'm just going to tell you how you proceed with this problem. So if you consider this to be a reference phasor, okay, if your 220 volt VRMS, if you consider this to be a reference phasor, ang ibig sabihin ng reference phasor, you assign an angle of 0. Assign a phase angle of 0 degrees. Right? So your voltage is 220 volts at an angle of 0 degrees volts. Then I can compute for my different phase angles because I know the power factors. I know my power factors. So I can compute for the angle of I1, I2, I3, and I4. You can compute for the angles of I1, I2, I3, and I4 from the power factors. And that's how you get the total load. That's how you get the total current supplied to the shop. Okay, but there's another method. There's an alternative solution. So that's how you do it, ano? So you get the phasor quantities of this, and then you can get the total phasor quantity IT by adding the phasors. But what is the alternative solution? The alternative solution is you get P total. P total is P1 plus P2 plus P3 plus P4. Okay? And alam na natin yung P1, P2, P3, P4, no? That's 2 kilowatts plus 3 kilowatts plus 500 watts plus 1 kilowatt. That's my P total. 2 kilowatts plus 3 kilowatts plus 500 watts plus 1 kilowatt. Okay? And then you can get your Q total. That's Q1 plus Q2 plus Q3 plus Q4. And how do you get your Q total? Gamitin niyo yung power triangle. Right? If I know S and I know P, I can get Q. So for example, in this case, okay, in the case for load 1, what is Q? No? Q1 here is just equal to the square root of S squared minus P squared. Right? This is from the power triangle. I know my S. Ito yung value ng S, no? 2.35. Right? I know my P. My P is 2,000. This is 2,350. I can get my Q. I can get my Q1. No? I can do that for L1, L2, L3, and L4. No? So what will this give me? No? So the total volt amperes, no? your total VA, no? Total VA total is equal to the square root of P total squared plus Q total squared, which is equal to V times I total. And since V is equal to 220, you can compute for I total. Okay. Unfortunately, I have to stop there. No, we exceeded the time I allotted. I actually had other example problems, but wala nang oras, ano? So there are two ways of solving this problem. One is using phasors. Ito, I will convert I1, I2, I3, and I4 to phasors. And the other one is just using power balancing. We call this power balancing, conservation of power. If you use this technique, like I said, you don't have to worry about complex numbers. Whereas using this technique, you'll have to worry about complex numbers. But like I said, that's not an issue because you have calculators that can do complex number calculations. So before I end, any questions? I'll have to end the session now because I have another class. Any questions?
Sir, one last clarification. Capacitive load, ibabaliktad dapat yung power triangle?
Basta capacitive load, you just use the power triangle, no? And then tandaan na lang ninyo na yung Q dapat gawin mong negative.
Okay, so hindi na po kailangan i-drawing na baliktad.
Yeah, you don't have to, no? Actually, para sa iyo naman to, no? This isn't for me, no? This is for you. This is for you to compute PQ from S. No? Pero pag sinabing leading ang power factor, then you always have to make Q negative pag sinabing leading power factor.
Okay, thank you.
Okay? Any other questions? Okay, so I'll have to end the class now, no? I'll post this notes for you and also the recording of the session. Okay, thank you.